Hi, this is the another example of synthesis of passive network. You can see this is the LC impedance function. We said LC is equal to the numerator part is 12 times s to the power 4 plus 9 times s squared plus 1, and the denominator 6 times s to the power 3 plus 2s. In a previous video, I explained the same example with first form. In this example, I discuss how to obtain the final circuit diagram using the first Cauer form. This is the LC network. It has only inductors and capacitors. In the Foster form, we are using partial fraction expansion for the impedance function. But in Cauer form, we are using continued fraction expansion for the first Cauer form. Before applying the Foster form or Cauer form, we have to check this function is realizable or not. In the previous video, I explained the realizability of this impedance function. Then this function is realizable. When we consider this function, the degree of the numerator is greater than the degree of the denominator. Then we can apply the continued fraction expansion for impedance function. This is impedance function. Now I write again the denominator 6 times x to the power 3 plus 2s is the denominator. The numerator is 12 times x to the power 4 plus 9s squared plus 1. I divide this part by this. From that one, I can obtain 2s. Then I multiply this by this term, 12 s to the power 4 plus 4 s to the power 4. Sorry, 2. Then remaining values are 0 plus 5 squared plus 1. Now I use this term in here, 6s to the power 3 plus 2s. Now I divide this term by 5s squared plus 1. From this one, the answer will be 6 over 5 times s. Now I multiply this by this term. It is 6s cubed plus 6 over 5 s. Now I subtract these two. 0 plus 4s over 5. Now I'm using this function to displace 5s square plus 1. Now I have divided this function by 4s over 5. From this one, answer will be 25s over 4. When I multiply this by this, I can obtain 5s square. The remaining part is 1. Now I use this one to here 4s over 5. Answer will be 4s over 5. And if I multiply this by this 4s over 5, the final answer will be 0. Now, if we consider these answers, this value will be impedance value, and this one will be admittance value. This one again impedance. I consider this as Z1. This one is Y1, Z2, and again admittance value Y2. Now all the impedance and admittance values are obtained. Now we have to construct the final circuit. If I consider Z1, answer is 2S. It is an inductor with the value of assume L1 is equal to 2. And Y1, it is 6 over 5S. It is a capacitor with the value of 6 over 5. Assume if the impedance of the capacitor is 1 over Cs and the admittance of the capacitor is Cs, then that C value is 6 over 5. And the second impedance value is 25 S over 4. It is an inductor. L2 is value is 25 over 4. And the last one is admittance value. The value is 4 S over 5. It is a capacitor. C2 value is 4 over 5 according to this admittance value. Now we can construct the final circuit. The first value is impedance value, series connected inductor. Second one is capacitor, it is connected with parallel. And the third one is inductor, and the final one is capacitor. Values are 2 Henry, 25 over 4 Henry. This capacitor is 6 over 5 farad, and this capacitor is 4 over 5 farad. This is inductor 1, inductor 2, capacitor 1, capacitor 2. This is the final circuit that we can obtain from this impedance function. It has 2 inductors and 2 capacitors. In first Cauer form, in the general explanation, capacitors are connected in parallel to the circuit and inductors are connected in series to the circuit. You can see inductors are connected in series connection and capacitors are connected in parallel connection. That is the way we can obtain the final circuit diagram using the first Cauer form. I hope you all are clear about this example. Thank you.